Hi, my name is Mohammed Tariq, and today we will implement the delete functionality for the heap structure. In last lecture, we implemented insert functionality and we inserted some set of data into the heap, and we also saw how the code then makes the necessary changes to maintain the heap structure. I showed you in detail the code and the effect of the code on the heap structure. And I also showed you the changes in the array and the movement of values, the movement of the data in the array. So in the same way, we will implement the delete code, and I will also show you the array structure. So I have some set of data available. I have inserted some data in the heap. So let's print these, and then I will draw the heap structure here on my right hand side in this PowerPoint presentation, and I will also show you what is the current structure in terms of the tree. So let's print this first. Heap dot print. Let me call the print statement and let me run this code. I'm running this code. So as you can see here, I have a structure. So if you read this first line, I have parent with the node 3, then I have a left child with 5, and I have right child with the number 6. Is actually the data which is 6. Then if you read the second line, I have 5. Now 5 is the parent now, and its left child is 9 and its right child is 84. Then I have 6, its left child is 19 and right child is 17, and the last one is 9. Let's draw this. Let's draw this structure here. So I have 3, right? Then I have 5 as a left child, 5, and I have 6 as a right child. And then I have 5, and the left child of 5 is 9. It's 9, and the right child is 84, right? 84. And the left child of 6 is 19, and the right child of 6 is 17. Okay. Then the left child of 9 is 22, and the right child of 9 is 10. So this is the current structure I have, and we can also draw this in the array also. So let's take an array, and how many elements I have? I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have 3 here, then I have 5, then I have 6, then 9, then 84, then 19, 17, 17, 22, and 10. Okay. So now let's implement the delete operation. Let me write a function here, public integer remove, and I will pass nothing, right? Because we are maintaining and we are implementing heap. So only the root value will be removed. We need not to pass anything. And then the tree will adjust itself based on the rules of the heap. Or we can say tree or the array, we will write the implementation of that. So int, and I can say popped, the value that we will get is equal to, we can say heap, whatever is on the index number 1. Okay, we can get that. Now once we have the value, now which value will replace the value on the index number 1? So for this, what I am going to do is I will say 1, and what I will assign in this is I am assigning the last value, right? So you remember that we have variable with the name size. Size is actually maintaining the number of elements in the array, right? It's not the size of the array, it's the number of elements in the array. Now I need to maintain, or you can say I need to adjust that heap according to the rules, because I don't know the last value is the least one or not. So for that I have a method. So for the sake of saving time, I will copy that method here, and then I will debug that method, and I will show you line by line the working of the code. I can also write the method in front of you, but that will take a bit of time. That's why my strategy, as I also discussed in the last lecture, that I will copy the code, and then I will debug this code for you, and line by line we will investigate what's happening on every line and what effects it has on the structure, on the tree structure or on the array. So now as you can see here, I have a method now. I have copied a method which is min-heapify. So what this method is doing, this method will adjust, or you can say this method will restructure the heap so that the minimum value should get the root node. Okay, so the minimum value should be on the root. So this is the purpose of this method. I will call this method min heapify, right? And I will pass the index number here, right? And the index number will be 1. All right. First, I'm copying the last element in the index 1, and then I'm calling the heapify method, and heapify then from root node. It will check for the minimum value, and then it will copy that minimum value, or it will transfer that minimum value to the root node. And lastly, I'm returning the popped value, the value of the root node, right? So let's mark this line as a breakpoint, and let's call this method from here, say heap dot remove, right? And as I'll call this method from here, so let's mark the first line on heapify method as a breakpoint. And now let's check. Now let's check. We have a structure ready, and we can now examine and we can do the analysis of the code and the effect of the code on the structure. Let's debug this. Okay, so remove method has been called, and now we are on the first line of remove method. Now we have which value? We have 3, right? So the first element is 3. And now let's check. The size is actually 8. What is now in the heap? So let's check what is now in the heap. So in the heap, the value is 10. So what happened actually is, if you look at on the PowerPoint slide, so the value of this, so the last value has been copied to the root node, right? So now let's, according to the code, let's remove this and let's write 10 here. Okay. Now we have 10 here. Now let's come back to the code, and now we are calling heapify. So now let's go to the heapify method. In heapify method, the first line says is leaf. So we are passing the index number here, and we are checking, is this the leaf node? And if it's not leaf node, as you can see the exclamation mark here, it means not. If it's not the leaf node, then condition will be true. Otherwise, it will come out. So yes, it's not a leaf node, so it will come inside. Now here, what we are checking, you see, we are checking two conditions. We have OR operator here, the double OR operator. The first condition is, whatever is in the current position, is this less, or sorry, is this greater than the left child of the current position? Okay, so let's suppose, so now actually we are standing on the first, or you can see the root node, which is this one, right? So we are actually standing here. We are standing at this point. So now we are checking, if this the current node, which is 10, as you can see the value here 10, is this greater than the left child? You see here we have the left child of the current position. So the left child of the current position is 5, right? This is the left child of the current position. Is this greater than this? We are checking this one, and yes, this is, the root is greater than 5. Or we are also checking that the root node, right, whatever is in the root node, because we are currently standing at the root node. Is this greater than its right child? Here we are checking with the right child. So if we check the right child, it is all no. The right child is not greater. We will enter in this if block. Now here we are checking if left child is less than. If left child is less than right child. So now in this case, we are comparing these two values, right? We are comparing these two values. Okay, so we are comparing 5 with 6, and which one is lesser? Which one is lesser? We are comparing this because we want the least value, the minimum value. So it says if left child is less than right child, and yes, here in this case, left child is less than the right child. So this condition is true. Now we are here, and now we are swapping. So what we are doing, we are swapping with which position? With position 1. We are swapping the left child with the root position, right? So what is the effect here? So actually we are swapping 5 with 10. So the result will be something like this. 5 is here and 10 is now here, right? After this step. And now you see we are again calling Heapify recursively, right? We are calling Heapify recursively because we need to check this remaining tree. Okay, we need to check this remaining structure, right? Now we are here and we are calling Heapify. Now the index number is 2, and why the index number is 2? Because we have swapped the values. So the current value of 10 is index number 2, right? So here if we make the change in this array, so the 5 will be moved to 1. So the 3 has gone. 3 has gone. So here it will be 5 and we will have 10 here. So the index number of 2 is, sorry, the index number of 10 is, which is 2, right? So now the same checking again, that if the current position is greater than its left child or it's greater than its right child. Now we are checking if left child is less than its right child, right? So in this case we can see the left child is less than the right child. Right child is 84 and the left child is 9. So 9 is less than its right child. So now we are inside this if loop. The condition is true, and then we came inside this if condition, and now we will swap. Because 9 is less than 10, we will swap 9 with the 10, right? So let's swap the values. Let's swap these values, and here we will have 10 and here we will have 9. Okay, so now we have swapped the values now, and then we are again calling min Heapify because we still have nodes available. So now we will check if is leaf is leaf is this condition is true. So let's check the is leaf method. So is leaf method is saying that if current position is greater than or equal to the size, the half of the size according to the array. So the changes that we want to make in the array is, now we have 10, the current position of 10 is not 2, right? So let's remove this from here. Current position is not 2, the current position is 9. So here we will write, here we will write 10 and here we will write 9. So the is leaf method says if the index position is greater than or equal to the current size. So okay, we are actually standing here, and 4 is of the half of the size. The size is actually the number of elements in the array. So we are at the halfway in the array. So this condition will be now false, right? And now we have came out. So now if you see, the pointer came to the Heapify, because it is also possible that there may be some statements after this, right? There may be some statements written after. So then it will execute those, but in this case we do not have anything after this. So now here we came out. Then again it will go back to heapify because it was called twice. As you saw, now you see it has came back to heapify to have any value, to have any statements to execute after this, because it was a recursive call. This came out, and now the heapify method has been completed. Now we can return the value. So this is the functionality of remove method. And after removing the element, we restructured the heap, and I showed you the changes in the tree and also in the array. We need to make a simple change. So the only change that we need to make is, what we can do is, here, because we need to nullify this element, right? We need to nullify this element, or you can say we should remove this from here, right? So for that purpose, because it's an integer, heap, this heap is defined as an integer heap. What we can do, we can write a simple statement here, which is heap of size minus minus, and let's let's mark that as 0, right? We can mark that as 0, or we can give some negative value if we have a condition that our array will only have positive integers. So, and negative integers will indicate that there is no value. So we can assign in a negative integer here. So this is the change we can make. So I hope this will be helpful for you, and I want you to practice this. I want you to write your code on your own. I will see you in next lecture. Thank you.